temperature, and olive oil is liquid at room temperature.
I know they are both lipids and we call them both fats, but I wonder what makes them look and act differently.
Well, we are twins, and we look and act different. So maybe the butter and oil are just like us. A few simple things make us different.
That could be it. Let's look closer at what makes butter and olive oil act differently.
That sounds like a great idea.
Butter and olive oil both contain fatty acids, which are carboxylic acids that typically contain between 12 and 20 carbon atoms. Fatty acids differ from each other by the number of carbon atoms they contain and in their number of carbon-carbon double bonds. Saturated fatty acids have only single bonds. Monounsaturated fatty acids have one double bond. Polyunsaturated fatty acids have two or more double bonds.
Jack, that sounds like we are getting closer to figuring this out. I wonder if what makes the one solid at room temperature and the other liquid have something to do with the bonds between carbon atoms.
I think you are onto something. Let's look further.
Single bonds between carbon atoms allow for the fatty acid tails to lie close together, which enables the London forces to be stronger, therefore making them harder to break apart and the melting points to be higher. Here you can see examples of saturated fatty acids and how they have high melting points because of the single bonds. The higher the melting point is also relevant to the number of carbon atoms. With unsaturated fatty acid, the cis double bonds that are made and don't enable the fatty acid tails to lie up close together, making the London forces weaker. Therefore, they can break apart easier, making the melting point far lower than saturated fatty acids. Here you can see examples of unsaturated fatty acids. You can see that the melting point becomes lower with the increase of double bonds. Animal fats such as butter and vegetable oils such as olive oil are called triglycerides. Triglycerides are three fatty acid residues joined to glycerol by ester bonds. What makes a triglyceride a saturated or unsaturated fat depends on the fatty acid residues attached to the glycerol. For a saturated fat, there must be 2 or 3 saturated fatty acid residues joined to the glycerol. For an unsaturated fat, there must be 2 or 3 unsaturated fatty acid residues joined to the glycerol. So butter is solid at room temperature because it has more saturated fatty acid residues joined to the glycerol, making the London forces stronger, giving it a higher melting point. Olive oil is liquid at room temperature because it has more unsaturated fatty acid residues joined to the glycerol, making the London forces weaker, giving it a lower melting point.
Dylan, that is like us. You are great at gymnastics and I am not. Maybe you are full of double bonds and I am full of single bonds. That makes you the oil and me the butter.
Jack, you are silly. Well, I think we answered our question. Butter is solid at room temperature because it has more single bonds, so the London forces are stronger.
And olive oil has more double bonds, so the London force are weaker and so is liquid at room temperature.